the main distribution panel main breaker is equipped with a shunt trip device, then it meets code as a sufficient means for providing an emergency shutdown for the branch panel that feeds the forklift battery charger circuits. The shunt trip is a mechanism that allows the circuit breaker to be tripped remotely, providing a convenient and effective way to energize a circuit in an emergency situation. The National Electrical Code, or NEC, doesn't explicitly define every specific scenario requiring emergency shutdowns, but it focuses on ensuring safety and preventing hazards. The use of a shunt trip on the main breaker feeding the branch panel satisfies the general intent of the code. This is because it allows for a rapid and reliable means of cutting off power to the battery charger circuits in case of a malfunction, fire, or other emergency. Several sections of the NEC are relevant when considering the installation and use of shunt trip devices for emergency shutdowns. These sections provide guidance on the requirements for emergency systems, disconnecting means, and overcurrent protection. Firstly, NEC Section 700 covers emergency systems. While forklift battery chargers might not fall under the typical definition of emergency systems like those for lighting or life safety, the general principles of providing reliable power cutoff in emergencies are still applicable. Section 700.1 states that emergency systems are those systems legally required and classed as emergency by municipal, state, federal, or other codes, or by any governmental agency having jurisdiction. Even if the forklift charger circuit isn't legally mandated as an emergency system, the safety intent is analogous. Secondly, NEC Section 230.70 addresses the location of disconnecting means. This section requires that the service disconnecting means be installed at a readily accessible location either outside of a building or structure or inside nearest the point of entrance of the service conductors. Although this section primarily applies to service equipment, the concept of having a readily accessible disconnecting means is important for emergency shutdowns within a facility. The shunt trip on the main distribution panel provides a readily accessible means of disconnecting power to the branch panel. Thirdly, NEC Section 240 provides requirements for overcurrent protection. Overcurrent protection devices, such as circuit breakers, are designed to protect conductors and equipment from overloads and short circuits. The shunt trip device adds an additional layer of protection by allowing the circuit breaker to be tripped remotely, even if the overcurrent protection hasn't activated. This is particularly useful in scenarios where a hazard needs to be mitigated quickly, such as a fire or equipment malfunction. Fourthly, NEC Section 430 deals with motors, motor circuits, and controllers. While forklift battery chargers are not motors themselves, the principles of motor circuit protection can be relevant, especially if the chargers have significant motor loads internally for cooling or other functions. Section 430.102b requires a disconnecting means to be located within sight from the controller. While the shunt trip on the main distribution panel isn't within sight of the battery charger itself, it provides a centralized emergency shutdown that can be more practical in a large facility. Fifthly, NEC Section 625 specifically addresses electric vehicle charging systems. Although this section primarily applies to charging systems for electric vehicles like cars, the general safety principles can also extend to forklift battery chargers. Section 625.23 requires overcurrent protection for charging equipment and charging cables. The shunt trip on the main distribution panel complements the overcurrent protection by providing an additional means of disconnecting power in an emergency. To ensure compliance with the NEC and other applicable codes, it's essential to follow best practices for the installation and testing of shunt trip devices. The shunt trip mechanism must be properly wired and connected to a readily accessible control device, such as a clearly labeled emergency shutdown button. The control device should be located in a safe and easily accessible location away from potential hazards. Firstly, proper wiring is critical to the functionality of the shunt trip device. The wiring must be sized appropriately for the voltage and current requirements of the shunt trip coil. The wiring should also be protected from physical damage and environmental factors. Secondly, the shunt trip device should be tested regularly to ensure that it is functioning properly. Testing should involve activating the shunt trip from the control device and verifying that the main breaker trips as expected. The testing should be documented and records maintained for future reference. Thirdly, the emergency shutdown system should be clearly labeled and marked. The location of the emergency shutdown button should be clearly identified with signage that is visible and easy to read. The signage should also indicate the equipment that is energized by the shutdown system. Fourthly, personnel should be trained on the proper use of the emergency shutdown system. Training should cover the location of the shutdown button, the procedures for activating the shutdown, and the potential hazards that the shutdown is designed to mitigate. Fifthly, consider integrating the shunt trip system with other safety systems in the facility, such as fire alarms or gas detection systems. This integration can provide a coordinated response to emergencies, ensuring that power is automatically shut off to potentially hazardous equipment. In the context of an OSHA inspection, the inspector is primarily concerned with ensuring a safe working environment for employees. The presence of a shunt trip device on the main distribution panel, providing emergency shutdown for the forklift battery charger circuits, demonstrates a commitment to safety and can help to satisfy the inspector's concerns. Firstly, OSHA standards require employers to provide a safe workplace for their employees. This includes protecting employees from electrical hazards. An emergency shutdown system for forklift battery chargers helps to minimize the risk of electrical shock, fire, and other hazards. Secondly, OSHA inspectors may look for evidence of a comprehensive safety program that includes procedures for identifying and mitigating hazards. The installation of a shunt trip device, along with proper training and documentation, demonstrates a proactive approach to safety. Thirdly, OSHA may reference the NEC as a recognized source of safety standards. Compliance with the NEC, including the provisions for emergency systems and disconnecting means, can help to demonstrate compliance with OSHA requirements. In summary, using a shunt trip device on the main distribution panel main breaker is generally considered sufficient to satisfy code requirements for an emergency shutdown of the branch panel feeding forklift battery charger circuits. It's essential to ensure proper installation, testing, and labeling of the system and to provide adequate training to personnel. Consulting with a qualified electrical engineer or inspector can provide further guidance and ensure compliance with all applicable codes and regulations.